Welcome back, everybody. Hope you guys are doing okay. Please don't forget to subscribe and like this channel for further and more helpful videos. Today we'll be talking about Ohm's law here. As we said, Ohm's law states that in a circuit it requires 1 volt to push 1 amp through 1 ohm resistor. That's Ohm's law right there. So, and the formula or the statement of the Ohm's law, it should be correct for all these three things, because these should be alternating between these three things. This should be for voltage, this should be for amperage, and that should be for resistance. If we have one of these available, two of these known, we can find the third one. As you see, if we have a intensity of amp, intensity of current, and resistance, we can find the voltage. Or we have a voltage and resistance, we can find the amperage, and so on. So that should be our Ohm's law equation there. Now we're going to the power equation. Before we do that, resistance is measured in ohms, and that's already amperage there, and V is voltage, or as from the name we can say it. Power will be watt in this section. So P is equal to V time I, or the voltage time amperage. So that is our equation for that, and we can alternate these three also, because we have three variables, so we can just write it down as a three different ways. This for the power, V equal to P over I is for the voltage when we have power in amperage, and when you have power in voltage and you are asked to find the amperage, you can use this equation. We can manipulate this equation, because since we have Ohm's law and this power equation, we can substitute something and come up with something. So that being said, this is V is equal to, this is V actually, the voltage is equal to I time R, and the equation for the power was, this is our V right here. So we substitute V from the Ohm's law in here, and we will end up with this one, I squared, or square of amperage time resistance. And same thing, we will just substitute, because I here is equal to, in Ohm's law, I is equal to V over R. So we will substitute I with this thing. This is our I, and we will get V squared over R, because you will multiply these two, will V time V will be V squared over R. So this is for the power, the third equation. Okay, let's go on to the examples here. A light bulb has a power rating of 60 watts and it draws 1.5 amp current. What is the resistance of the bulb circuit? Okay, so we are given items are so what is given? Given P is equal to 60 watts, and I is given also 1.5 amps or amperes. We are asked to find the resistance. We'll asked to find R. So what is R? We call it X, or we call it unknown, whatever you call it. So we have equation here. So if we have a P and I, but you don't have a R, so we will use this equation, which will be P equal to I squared time R. Since we are asked to find R is equal to P over I squared. Okay, so we can find a R here, or resistance here, P divided by I squared. R is equal to, P was 60 watt, and amperage is 1.5 squared. So 60 watts, 1.5 square will be 2.25. 60 divided by 2.25 will be 26.6 repeated 7 with 26.67 ohms. So our resistance should be 26.67 ohms. So that's how we find it. Now let's go to the second example here. If an LG TV 65 inches has a power rating of 115 watts, okay, let's as we will write down the equation, the quantities or the given entities that we have. So 115 watts is given from the equation, and the voltage from the outlet of the wall is 120 volts. Find the following. Okay, what do we have to find? Current, we have to find the I and then resistance too. So we have two unknowns. So let's go on. We had an equation that P is equal to I time V. We can't use this one. We probably have to use the other kind of it, where we have this guy, which was if we substitute this one, and we will use this equation, V squared over R. So where we need to find R right here, we'll find this guy first. R will be equal to V squared over P. So let's see, R is equal to resistance is equal to V squared. It will be 144 with 2 zeros because V squared. Let's do it the way we can do it. It's 120 volt square over P was 115 watts. 120 square is 144. 120 square is 1440. I'm sorry, 14,400. 14,400 divided by 115 divided by 115 will give us 125.217 ohms. So this is 125.217 ohm, or we can just round it 125.2 ohm. Now we have to find the amperage here. For the amperage, we can use either equation because we find a V. We already have a V and we have a P both. So we can do this way. I is equal to, it'll be P over V. P is 115 and voltage is 120. 115 divided by 120 will give us 0.95. 0.958, so we'll round it up, or approximately to 0.96 amp. So there'll be 0.96 amp. So that's how we solve it. All right, let's move on to the next section. Will be resistors. Resistors are used in a circuit to limit the flow of a current, or it's also been used to divide a voltage divider as a voltage divider. We will talk about this one, the limiting the flow of current, because that's how we use it in the basic electrical studies. And voltage divider, we will talk about that some, but this will be in the next courses if we have to follow. That'll be next thing. So resistors are divided in two different kinds: the fixed resistors and variable resistors. Fixed resistors are defined as resistors that with 1 ohmic values that cannot be changed. So they have a one flat ohms value that will not change, whereas variable resistors will change, or they will varies in their values. So they have a some sort of like potentiometer or variable resistor that, like, you can make more resistor or less resistor by like a radio knob, which will be a variable resistor example. And fixed resistor has a different kind. They use different metals, different substance to have a resistor. Like for example, metal film resistor. They use metal to create resistor. Carbon film, and also metal glaze. This is different from here. Metal film resistor and the metal glaze resistors are different because they're using metal in the glass in the combination of these two. Now the fourth one will be wire wound resistor, which is a very high temperature tolerant. That means that they have some sort of cylindrical shape. They wind wires around it. They will make a tubing kind, so they will, and if they have to mount it, they will be mounting in a vertical position. So where in the hole in between that cylinder, they will be dissipating some air, so it will not get too hot. So that's why they're using them as a high resistance resistors there. As we defined, fixed resistors are resistors that only have a 1 ohmic values that cannot be changed, and we use them a lot. We will use them a lot. We will use them a lot in this class, in this class, you can say. Variable resistors are resistors which can have more than one values, or they can change their values. That's how we call it variable resistors. We will talk about two different things in this one: potentiometer and other variable resistor in this thing, which will have some sort of three knobs right here, so you can adjust these things. So this should be your potentiometer right here. These all usually have three terminals, 1, 2, 3. One should be the voltage, one should be the ground, and the other one is for the adjusting it, how much you want it. So let's move on to the color code. What is the color code in resistor? The color code is used to determine the value of a resistor. Okay, so how we, like, if you open a circuit board or something that is in the panel of electronics, you will see a lot of color coding there. Resistor usually contain 3 to 5 color bands. 3 bands has a tolerance of 20%. 4 bands has tolerance from 2 to 10%. 5 bands has 5 bands of color, or 5 bands color has 1%, which we use for military. These are all plus and negative values. Yeah, what tolerance is, I just had to define the upper and lower limit of our resistance, or anything that is tolerance. So we said, like, we know these 3 bands have this much tolerance, 4 bands 2 to 10 plus and minus 10%, and 5 bands has a plus and minus 1% tolerance. How we know these things? So there is a instruction for that. So if we are dealing with only 4 bands of color, the first 2 numbers are just number value, third one is a multiplier, the fourth one is tolerance. If dealing with 5 color bands, the first 3 are numbers value, and fourth one is multiplier, and the fifth one is a tolerance. So to deal with 4, the first 2 are the number. You just write down their numbers. We will talk about those numbers in next section. We have them. And the third one will be multiplier, and the fourth one is the tolerance. But if we have 5 bands, the 3 will be the numbers. You just write down those numbers side by side, and then fourth one is a multiplier, the fifth one is a tolerance. But if we have only 3 bands, what happens? We will talk about that next. Okay, example. Assume that a resistor has 4 bands, such as green, blue, orange, and gold. Find the value of the resistor. So, to solve this question, you have to go right here. So this is our value. It says like what colors codes are here. So it has 4 bands total. We said like the first 2 are the numbers, the third one is a multiplier, and the fourth one will be the tolerance. So let's say green, orange, green, blue, orange, and gold. So how we write this thing down? So let's say first one is green, which is 5. The second one is blue, which is 6. The third one is multiplier, which is orange, will be time 10 to the 3, because this is number 3, so it will be 10 to the power of 3. And the fourth one is the tolerance, brown, is plus and minus 1%. So plus time plus and minus 1%. So that will be 56,000. If we multiply that by 0.01, let's see if we have anything. It'll be 56,000. 0.01 will be 560 plus 56,000. That will be the upper value, plus 56,000. So the upper value will be 56,650. And now what is the lower value? 56,000 minus 560. So it will be the lower value. This is upper. Lower will be 56,000 times negative 0.01. That will make it, the number will be 55,400. 4,400. I'm sorry, 55,440 ohms. Okay, we'll have some more example here, don't worry. So the color codes are black 0, brown is 1. You can write it down, these things, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to 5. These are all multipliers, 10 to 6, 10 to 7, 10 to 8, 10 to 9. These are multiplier, and these are tolerance. No color band will be 20%. Silver is 10% minus positive. Gold is 5%. Red is 2 plus negative 2. Brown will be plus and negative 1. So let's see. A resistor has 5 color bands, such as red. So red has a what? Red has a 2. Solution will be 2. We see in the 5 bands, we said 3 are the numbers, 4th is the multiplier, 5th one is the tolerance. So red, blue, green. Blue is 6, green is 5. 6, 5. Now the 4th one here is yellow. Yellow is multiplier, which is the 4th band, will be 10 to the 4. And then the 5th one is what? Is the tolerance. Tolerance, we said which one is the 5th one is brown. Brown is plus time 1%. So let's find this thing. So there will be 265. 4 zeros will be added there. So make it, so one right here, 650,000 ohms. If you multiply that by 1%, that will give us an upper value, upper limit. So if you do that, 2,265,000,000, sorry, 2,650,000 times 1%, 265,000,000. So it'll give us 2,676,500 ohms. That is the upper limit. Now the lower limit will be, so the lower limit will be the ohmic value from the 4-band that we had will be 2,065,000 ohms time the lower limit negative 1% will give us 2,623,500 ohms. So that a resistor has 4 bands: brown, black, violet, and silver. Find the upper and lower limit of the resistor. We know the brown is 1 and black is 0. The third one is multiplier, which will be violet is 7, so it will be 10 to the 7 times 10 to the 7. And the fourth band is the tolerance. Let's see if the silver tolerance is 10%. With time plus negative 10% ohms. So let's find the value of the resistor first. Will be 10, and we will add 7 more zeros there, which will give us 3, 3, 6, and 7. So 1, 2, it'll be 100 million. 100 million ohms is the resistor. That's the resistor value. But the upper limit of the resistor will be 100 million. If you do that 100 million, if you multiply that by 10%, it will give us 10 million. 100 million plus 100 millions time 0.1 will be 10% will be 10 million. So the upper limit will be equal to 110 million ohms. 110 mega ohms. We can say also assigned metric notation 10 to the 6 we can say is million. We can say mega ohm. Now the lower limit will be 100 millions time negative 10%. So take this value out of there, will be 100 minus 100 minus 10 million actually. So it will give us 90 million. Ohms, or the lower limit will be 90 mega ohm. Okay, so that's how we find it. Now let's do one more example here. A resistor only has 3 bands: white, green, and yellow. Find the value of the resistors and show the upper and lower limit of the resistors. So we are asked to find white, green, and yellow. Let's go and check it here. White is 9, green is 5, and yellow is 4. So we're asked white is 9, green is 5, and the first two are our numbers. The third one is your multiplier, which is green will be 10 to the 4. It'll be 95. 1, 2, 3, 4. So it'll be 950,000. So let's check our work here first. Green is 5, yellow is 4. That's correct. So that's the ohm of the resistor, the ohmage of the resistor, 950 million. 950,000 ohms. We can write it down as a 950 kilo ohms because 1000 is kilo. Now we are asked to find the upper and lower limit. So if you don't have any fourth band, if the tolerance band is not there, that's automatically 20%. So we said 950,000 times 0.2 will give us 950,000 plus 190,000 will give us total of 1,140,000 ohms. Or we can say, let's not say it. We will not short it. Now the lower limit is 950,000 minus that number, 190,000. 950,000 minus 190,000 will give us 760,000 ohms. So that's how we find the resistors again. So that only has 3 bands. The first 2 bands are the numbers. The third one is the multiplier, and there is no fourth band, so that will be the tolerance will automatically go to 20%. Now let's move on here. The variable resistors we said before. There is a potentiometer and rheostat. The potentiometer is a resistor which is used to provide different voltage, and it is potentiometer is took from potential, which is a voltage. So we can control the voltage on that thing, like in our stereo. We can give it more voltage, boost it up, lower the noise, and that will be our potentiometer. Now rheostat is a variable resistor that has only 2 terminals, which is used to adjust the current in a circuit. This will adjust the current in a circuit. Potentiometer will adjust the voltage in a circuit. What voltage does? Voltage does push the current to go in a circuit. So a little bit different. So the fixed resistors, these are the resistors that doesn't change the value, does not change the value. Where the variable resistor, they will change the value. So this is a rheostat. And this is a potentiometer. Potentiometer has 3 terminals, and the rheostat has only 2 terminals to control. This one controls the current in a circuit, and the potentiometer or pot controls the voltage in a circuit, which will be in our stereos and car, anything that you have can adjust the volume of a music. That will be one of the examples potentiometer has. Hope you guys got something from this video. Please do not forget to subscribe this and stay tuned for the next upcoming lectures. And until then, see you guys. If you like this video, please do like and subscribe this channel for further more instruction. Thank you.